This is the 13.5 mini lesson, and today our teaching point is, today I'm going to teach you how to calculate the volume and surface area of square pyramids. So we all know what a pyramid looks like. A square pyramid means the bottom part of that is a square, not a rectangle. We need to know this because it's important to see the relationship between different three-dimensional figures. Okay, first of all, we're going to use our visual summary. And we're going to add in some of the vocabulary that we need for understanding pyramids. So first of all, we're going to fill this in. So you may have to pause this and write down some of these terms. We have the vertex. The vertex is the point that's formed by the intersection of all of the lateral faces. Lateral faces are all these triangle sides. So this top piece here is the vertex. So I want to make sure you pause and write the definition in. The base is the single polygonal face. So we have triangle, triangle, triangle on this side, triangle on the back. It's the one that is only one of them. So this would be the square here. So this is considered the base. Okay, the height is the perpendicular, remember makes a 90-degree angle, distance from the vertex to the base. So it goes from the top right down to the center of my square. A lot of times you will actually see this drawn in to indicate that that's the perpendicular. Okay, a lateral face, let's try back out slightly here. A lateral face, those are the triangular faces of the pyramid. So like this side here is a lateral face, this side here is a lateral face. So they have an arrow drawn here. It's this entire triangle would be a lateral face. So there are 4 lateral faces in this drawing. A lateral edge, those are the edges that are formed by the intersection of 2 lateral faces. Okay, so again, like this right there, that little line, it's where this triangular side and this triangular side come together. So it's just that little ridge right there. And the last term is slant height. Slant height is the altitude of the lateral face. So what that means is when we just look at a triangular side, so I'm only going to look at this triangle right here. The slant height goes from the vertex down to here, and this will also make a right angle. That's the slant height. It's on a slant, but it's the height of just this triangle. Okay, so you may have to go back. You may have to pause right now so that you can get all your definitions copied in. Then I want you to flip it over when you're ready. So now we're going to figure out how can I find the volume and the surface area of a pyramid. So our formula for volume is 1/3 base squared times the height. If you think about base squared, this gives me the area of the base, and this is the height. That looks very similar to what we did yesterday, or in lesson 13.4. Area of the base times the height gave me the volume. The reason this is 1/3 is if I took this and filled it up with sand, it would be exactly 1/3 of, if this would have been an actual solid square on the bottom, square on the top, if this would be the prisms that we worked with in lesson 13.4. So it's 1/3 of what we had in 13.4. So the area of the base times the height is what we did in 13.4. Now I want 1/3 of that. So let's start filling this in. Volume, capital V, equals 1/3 times base, that's 20, squared, times height. Here's the height of the entire thing, that's 24. Okay, so I'm going to just keep going here. Volume equals 1/3 times, follow order of operations. Exponents come before multiplication. 20 squared is 400 times 24. I'm going to just make these look like fractions. So I can easily simplify this. 3 goes into 3 once. Remember, it always has to be a top with a bottom. 3 goes into 24 8 times. I don't need a calculator because 8 times 4 is 32, and add the 2 zeros. And my units for volume are cubic, so I have 3,200 cubic centimeters. Okay, first I'm going to just use this formula for surface area, and then I'm going to kind of talk to you about why this formula actually should make sense for us. So surface area means every single surface combined. This piece of the formula are the 4 triangle surfaces, and this is the square. Okay, so I should understand that surface area is the area of every piece added together. What would the wrapping paper add up to? So square is length times width, or the side squared, or the base squared. So this is 20 squared. Okay, that I know right away gives me 400, so I'm just going to kind of work that one right down. Okay, so if I follow this formula, it's 2 times the base times 20 times S. S is the slant height, because remember, I'm wanting the area of this triangle and the back triangle and the side triangle on the other side. So times 26. Okay, if I multiply 2 times 20 times 26, I get 1,040. So the total surface area, so this is the area of the 4 triangles. When I add that up together, and area is in squared units. Okay, now I want to kind of talk about this piece of the formula right down here. So we know that the area of a triangle is 1/2 base times height. So if I go back to my picture in here, area of a triangle is 1/2 base times, it's really the slant height in this kind of a picture. And how many triangles do I have? I have one in the back, I have one on this side, and one on this side. So I need this formula a total of 4 times. So the area of all the triangles would be 4 times 1/2 times the base times the slant height. If I now simplify this, 2 goes into 2 once, 2 goes into 4 twice. I get the area of all the triangles would be 2 times the base times the slant height. That's where that came about.